Okay, this is 11.3. This is solving the radical expressions. And so radical equations are equations that have a variable in the radical, aka you've got square root stuff to deal with again. Now today, here's going to be your biggest issue. Extraneous solutions. Extraneous literally mean extra, but completely not real. So if an equation is, or if an answer actually works out, but it's an extra answer that doesn't make sense given the situation, we call it extraneous. Now remember, you can do anything you want to both sides of an equation. So that's what this is saying. AB can be a squared equals b squared because you squared both sides. But the only problem is that doesn't always work. Like it it doesn't always work because if it's a negative, like -1 does not equal 1. But when you square those, now they are equal. This would be an example of an extraneous solution. You can't have a negative number equaling a positive number. And remember, in the land of square roots, we're always, today in this chapter, we're always considering just the positive root of the answer. So let me show you what this means. This is kind of what we just talked about, that you can square both sides, and that's not a problem. So if I have the square root of x equals 4, then that means I can square both sides, and that will tell you that x equals 16. And that works because the square root of 16 equals 4. Woohoo! So let's see how this plays out. Now, I need to solve for that x, but do you notice that that x is inside this radical problem? Now, I can get rid of the radical by squaring it, but I can only do that if the radical is alone. You have to get the radical by itself. So look at what's around it. Let's get rid of the other stuff around it. Let's add 15 to both sides. Now I have 3 times the square root of x plus 1 equaling, what, that would be 9. Okay, now I need to get the radical by itself. Let's divide by 3. And the square root of x plus 1 equals 3. Woohoo! Okay, now here, this is where the fun begins. I need to get rid of that radical. I need to make that go away. And the only way to make that go away is to square this side. That makes this go away, and I'm left with x plus 1. But if I square that side, I have to square this side. And so now it equals 9. 3 squared equals 9. And I can solve this by subtracting 1. And x is supposed to equal 8. Woohoo! You solved it. The only problem is you have to check to make sure that 8 is an actual real number. If you plug it back in, 8 plus 1 minus 15, -6. Does that actually work? Well, yeah. 8 plus 1 is 9. The square root of 9 is 3. 3 times 3 is 9, minus 15 does equal -6. 8 is an actual real solution. I know that you could have done all of that in your head, so please do. The only problem is I can tell if you don't check, because some of those answers might be extraneous and you don't know it. So let's check out this one. Let's get the radical by itself by adding 2 to both sides. And 4x minus 19 inside the radical equals 7. All right. Let's square this and square that to get the radical gone. And I'm left with 4x minus 19 equals 49. Let's add 19. That would be, what, 68. Divide by 4. And x is supposed to equal 17. All right, x is supposed to equal 17. Let's check to make sure that works. 4 times 17 is 68. Minus 19 is 49. The square root of 49 is 7. Minus 2 is 5. That answer actually does work. Good job. Okay, now to solve a radical equation that contains 2 radical expressions, I can do that. Just make sure that each side has 1 radical expression. You can't square adding and subtracting problems. So I have a radical problem equals a radical problem. Guess what? Square, square. Now you have 3x minus 3 equals 2x plus 8. And now I go back to my solving equation skills. I have variables on both sides. Let's subtract the 2x. And I have x minus 3 equals 8. So let's add 3 to both sides. I have an answer of 11. And let's check to make sure that 11 makes sense. That would be the square root of 3 times 11, which is 33. Minus 3 is 30. Does that equal 2 times 11, 22 plus 8? Yep, the square root of 30 would equal the exact same thing, the square root of 30. Okay, hold on. Okay, why don't you pause the video here? Oh, sorry. And see if you can solve these equations and check your answer. Hold on. All right, did you get the answer of 12 and 7? And if you plug them back in, you have the square root of 56 on both sides. And if you plug it in over here, you got the square root of 6 on both sides. Nicely done, folks. Okay, on example 3, here's where things get a little interesting. Because I have a radical over here, but I also have an x over there. The only way to get rid of this radical is to square this. And I'm left with 2x plus 15. But if you square that side, you have to square this side. That's right, folks. Welcome back to quadratics. I know you've missed it. I can hear you groaning. And remember, with quadratics, we can't do anything unless it equals 0. So let's subtract the 2x and the 15. And now I have x squared minus 2x minus 15. Remember, these are your methods to solve them. Woohoo! Now, with quadratics, remember, with all of these, you are always going to get 2 solutions. 2 solutions. The only problem is some of those solutions might be extraneous. Well, I have x squared by itself, and I'm going to try factoring. Can I think of something that multiplies to negative 15 but adds to negative 2? Yeah. X minus 5 and x plus 3. That would multiply to give me negative 15 and add to give me negative 2. That means either x minus 5 equals 0 or x plus 3 equals 0. So my answers are 5 or negative 3. Now, they might both work. Neither of them might work. Let's check it out. If I plug it back into the original equation, that's 5 equals the square root of what? 10 plus 15, which is 25. This one does work out. Here, this is negative 3 equals the square root of 2 times negative 3. Negative 6 plus 15 would be 9. And I know that the square root of 9 we've thought before is positive and negative 3, but now we're in the land of root principles. Principal roots, excuse me, which are only the positive. Negative 3 is considered extraneous, and your only answer is 5. That's the only way for a square root to equal a positive answer. So that's how the extraneous works. All right, let's test your quadratic skills and see how you do. Pause the video and see if you can get the same answers I do. Go. All right, how'd you do? I squared both sides. I got it to equal 0. I factored, I zero product propertied, I answered. But the square root of, but negative 5 cannot be an actual answer. It's extraneous because the square root of 25 is not going to equal negative 5. Over here, squared both sides, got it equal to 0, factored both sides, zero product property, and I have my answers. But negative 1 cannot be an actual answer because the square root of 1 does not equal negative 1. But over here, 7 is an answer. Circle. 7 is an answer because the square root of 49 does equal 7. And that is solving, except for that's not the homework you're doing. You're only going through 30 and 31. Yay, fun. All right,